Let us start CBSE Mathematics Class 10, Exercise 6.2, question number 7. You see the question number 7. Using the theorem 6.1, prove that the line drawn through the midpoint of one side of a triangle parallel to the another side bisect the third side. Now you see here given that the triangle ABC, D is the midpoint of AB, that is AD is equal to BD, and DE is parallel to BC. So here you see the D is the midpoint, therefore the AD will be equal to DB or BD, and DE is parallel to BC. We have to prove that the DE will intersect AC at its midpoint. Now let us proceed. We have to prove that E is the midpoint of AC. Therefore, AE is equal to CE. Proved in figure ABC. In triangle ABC, DE is parallel to BC. By Thell's theorem, we have AD by BD is equal to AE by CE. That is 1. Why it is 1? Because AD and BD both are equal. So when we divide it, you will get 1. So AE by CE is equal to 1. Just by cross multiply, you see here, AE by CE, that will be equal to 1 by 1. On cross multiplication, we have AE is equal to CE. That is proof that E is the midpoint of AC. Hence, proved and QED. Now proceed to the question number 8. It states that using the theorem 6.2, prove that the line joining the midpoint of any two sides of the triangle is parallel to the third side. Here you see, given in triangle ABC, D is the midpoint of AB and E is the midpoint of AC. So D and E are the midpoint. And while joining the DE, we have to prove that DE is parallel to BC. Now, there are two possibilities that D is parallel to BC. Second possibility is that D is not parallel to BC. If you are taking that D is parallel to BC, it was to be proved. Now, there is no need of any proof. But let us proceed from DE is not parallel to BC. At that time, what will happen? Let us proceed from the second case, that is D is not parallel to BC. Then from point D, draw a line parallel line DE dash parallel to BC. Because we have assumed that DE is not parallel. At that time, then we will draw a parallel line DE dash to BC. By basic proportionality theorem, at that time, AD will be equal to DB. That will be equal to AE dash upon E dash C. You see, the AD upon DB is equal to AE upon EC. It is given, that is equal to 1, and D and E are the midpoint. D and E are the midpoint. Therefore, these two, the ratio will be equal to 1. So, as AD by DB is equal to 1, D is the midpoint of AB. Hence, AE dash upon E dash C equal to 1. AE dash is equal to E dash C, that is E dash is the midpoint. Where as it is given that E is the midpoint of AC. It is already given that E is the midpoint of AC. But from our assumption, we have reached to the conclusion that E dash is the midpoint. So it shows that the AC line segment has two midpoints, which cannot be true. Therefore, first possibility, that is the D is parallel to BC, is the correct. Therefore, QED, which was to be proved. Now proceed to the question number 9. Question number 9 states that ABCD is a trapezium in which AB is parallel to DC and its diagonal intersect each other at the point O, so that AO upon BO is equal to CO upon DO. You see here, ABCD is a quadrilateral. Here ABCD is a trapezium. It is already given that ABCD is a trapezium where AB is parallel to DC, diagonal AC and BD intersect at O. We have to prove that AO by BO is equal to CO upon DO. Construction: draw OE parallel to AB. That is, OE is parallel to CD. Once we have drawn a line parallel to AB, and AB is already parallel to DC because it is a trapezium. Therefore, OE will be also parallel to DC. Now, prove in triangle ABD. In triangle ABD. In triangle ABD, OE is parallel to BA. OE is parallel to BA, and therefore DO upon OB will be equal to DE upon EA. DE upon EA. That is basic proportionality theorem. And you see, this can be inverted. So at that time, EA upon DE, EA upon DE will be equal to OB upon DO by invertendo. In figure DCA, in triangle DCA, this is DCA. OE is parallel to DC. OE is parallel to DC. So, EA upon ED. EA upon ED will be equal to AO upon OC. AO upon OC. By basic proportionality theorem. From 1 and 2 we have, see, this is second and this is first one. So from first and second we have EA upon ED, EA upon ED is equal to AO upon OC, and that will be equal to OB upon OD. Now by alternando we have AO upon BO. You see, just by changing the place of these two, AO upon OB means OB will come here and OC will go at this place. So AO upon BO will be equal to CO upon DO, and it was to be proved QED. Now proceed to the question number 10, which states that the diagonal of a quadrilateral ABCD intersect each other at the point O such that AO upon BO is equal to CO upon DO, so that ABCD is a trapezium. Now see here, question number 10, given that ABCD is a quadrilateral and AC and BD are the diagonal which intersect each other at O. and AO upon BO, AO upon BO is equal to CO upon DO. It is given. We have to prove that ABCD is a trapezium. Construction: draw OE parallel to DC. Now construction OE is parallel to DC. The proof: in triangle ADC. In triangle ADC, OE is parallel to DC. OE is parallel to DC. Therefore, AE upon ED will be equal to AO upon OC by basic proportionality theorem. And AO upon BO, AO upon BO is equal to CO upon DO. AO upon BO is equal to CO upon DO. It is given already. AO upon BO is equal to CO upon DO. That can be changed like this. You see, AO upon OC. This CO will come to this place and BO will come to this place as the numerator part. So that is known as alternando by AO by OC is equal to BO upon DO. Now you see, BO upon OD is equal to AE upon ED, that is OE is parallel to AB. OE is parallel to AB by converse of the basic proportionality theorem. You see, it is already, we have proved that BO upon OD is equal to AE upon ED. This implies that OE is parallel to AB by converse of basic proportionality theorem. If the ratio is given, it means it can be only possible when OE is parallel to AB. Hence, OE is parallel to DC and OE is parallel to AB. Therefore, DC is parallel to AB. Hence, ABCD is a trapezium because one pair of opposite sides are parallel to each other, and it is a trapezium, QED.